Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we are solving the questions of GATE 1999 and we have completed section B. Today we'll see section A of 1 mark and then we'll see 2 marks question. Okay, so these question I don't think so there is a need to solve, but still as I committed, so I will solve these questions, but these questions don't need much explanation. So we'll see first question. The system of equation is so straightforward, is no solution. You can see 2 by 5, 2 by 5, 2 by 5. Okay, so no solution. Okay, so no solution is there. Okay, so basic maths, like a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So it is no solution. No solution, right? That kind of thing. 4 fair coins are tossed simultaneously. Okay, the probability at least one head. Okay, so if 4 fair coin tossed, then 2 to the power is equal to 16 will be the total outcomes. Okay, so at least one head, that means one or more than one. Okay, one or more than one head. That means there should be a outcome tail, which does not have head. So if I 1 minus 1 by 16, if I will do, then I'll get 1 is the total probability, 1 is the tail divided by 16 total outcome, so 15 by 16. Okay, so now rank of the matrix. See, rank of the matrix you can find very easily. How? Remember this point. Rank is R, rank R if R plus 1 determinant equal to 0. If R plus 1 determinant not equal to 0, then rank is R plus 1. We'll see here. See, if I'll take this 3 cross 3 determinant and this 3 cross 3 determinant, more than maximum rank of this matrix should be 3. So first we will see 3 cross 3 matrix. So first I will take this. So 3 0 1 4 7 3 and 1 7 2. If I will solve this, I will get 0 determinant. Now I will take this and this. I will not take this. Okay, so you'll see. So 0 1 2 7 3 3 7 2 1. It will give 0. So both the 3 cross 3 determinant is 0. Both the 3 cross 3 determinant is 0. That means what I said, rank is R if R plus 1 is 0. That means 3 cross 3 is 0. So rank should be R. Rank should be R. For rank to be R, the R determinant should not be 0. That means we will check all 2 cross 2 determinant. All 2 cross 2 determinant we will see now. Okay. All 2 cross 2 determinant we will see. So first 2 cross 2 determinant, this, then we will see this. If any one of this 2 cross 2 determinant is non-zero, the rank is 2. So see, first itself is non-zero. 3 0 4 7. 7 3 is 21 minus 0 is equal to 21, which is not equal to 0. So rank is 2. Okay, so rank is 2. Don't go further. Rank is 2. That's fine. Okay. Harmonic series, not in syllabus. Now, a solution of specific gravity 1 consists of 35% A by weight and remaining B. Okay. So for complete reading of the solution question, if the specific gravity of A is 0.7, the specific gravity of B. Okay. So we'll see the specific gravity. So very first, let 100 gram of solution, mass of a 35 kg. Okay, we are taken in kg, so I will take kg. Okay, and mass of B is 65 kg. Okay. Specific gravity of A is 0.7 we have, and we know that specific gravity is rho A upon rho water. Density of A and density of water with respect to water. Similarly, specific gravity of B is equal to, let X, density of V upon density of water. So density of A will come 700. We know density of water is 1000. Density of water is 1000. Okay, so and similarly density of B is, now we know that volume is equal to mass upon density. We will apply this formula. So VA is equal to, we have that 35 kg of mass of A and 700 kg we have just found, so it is 0.005. Similarly, volume of B. Now density of solution, mass upon volume. So total mass of solution, it is solution, and total volume will be this. Okay. So specific gravity of solution, density of solution upon density of water. So density of solution upon density of water, and which is given to 1. So X will be 1.3. So this is our answer. Okay. Now, so 1.3 is our answer. Okay. Pure A in gas phase enters reactor. 50% of A is converted to B through reaction A that gives 3B. Mole fraction of A in the exit stream. Let 1 mole of A enter in the reactor. 50% conversion. 0.5 mole of A react. So 0.5 mole of A remains unreacted. Okay, A is equal to 3B. So according to stoichiometry, mole of A, 0.5 mole of A, 1.5 mole of B. Okay, so A is 0.5, B is 1.5, and total moles will be 2. Okay, so we have to find the mole fraction of A. So 0.5 divided by 2 is equal to 0.5 divided by 2. So 1 by 4. Okay, so 1 by 4 is the answer. Okay. Which of the following is true for Viral coefficient? C. They are only the function of temperature. This one. Okay. A gas mixture of 3 components is brought in contact with the dispersion of an organic phase in water. So first write F is equal to C minus P plus 2 minus R minus S. Degree of freedom. F. Component. Gas mixture of 3 components brought into 3 component minus with a dispersion of an organic phase and water. Organic phase and water. Organic phase and water. So phases is 1. Water is liquid. Organic phase is 1. Oh, sorry, water. Liquid, sorry. Organic phase is liquid, water is liquid. So 1 plus 2 for temperature and pressure. No reactions involved. Contact with the dispersion of an organic phase. No specific constraints. So F 5. Sorry. 3 plus 2 minus 1 is equal to 4. There might be some changes in the answers, but I feel it is 4. Just go to the other solutions as well. Okay, I might be wrong. Okay, a pipe of internal diameter 4 meter is bifurcated into 2 pipes, internal diameter 2 meter each. If average velocity of water flowing through a main stream 5, average velocity to bifurcated pipes. Okay. So see, a pipe of internal diameter. So this is 4 meter. 2 meter, 2 meter. Okay. Q1, Q2, Q3. If average velocity of water flowing through the main stream 5 meter per second. Average velocity through bifurcation. Okay. So Q1 is equal to Q2 plus Q3, and since both are of 2 meters, so Q2 is equal to Q3. So Q1 is equal to 2Q2. A1 B1 is equal to 2 A2 V2. I can write this d1 is square v1 2 into d2 square v2. So d1 is 4 4 just 16, velocity is 5, 2 into 4 into v2. So 4 to the 8, 8 to the 16. v2 is equal to 10. v2 is equal to 10 meter per second. Similar, v1 is equal to, sorry, v3 is equal to 10 meter per second. Now, average velocity, so q is equal to average velocity, so 10. Okay, average velocity will be 10. In centrifugal pump, cavitation occur with pressure of impeller I-bend. Cavitation. For cavitation, local pressure must be equal to vapor pressure of liquid to avoid cavitation. So less than the atmospheric local pressure must be equal to the vapor pressure, equal to or more than the liquid vapor pressure, ठीक है, equal to must be equal to or more than okay, liquid vapor pressure. These type of question we have solved, so I will not answer this question. And this is from organic question. Then we have a special condition of laminar flow. Okay, we have solved in many times. This question also we have solved many times at low Reynolds number. Power number is at low Reynolds number, at power number. We have solved these questions in 1993 or 1994. I will not solve this. Gives phase rule, find application when heat transfer occur. So this is the answer, condensation. Okay. As the difference between the wall temperature and the bulk temperature increases, the boiling heat transfer coefficient. So we know that there is a graph. Between temperature and like this. So this is burnout point. This is critical heat flux or burnout point. This is a Leidenfrost point. If I am not wrong, I have studied 2-3 years back. So okay, so it goes through a maxima. Okay. So this is the explanation you can read. Okay. In pipe flow, heat is transferred from hot wall to liquid by forced convection and conduction. Okay. So this is the explanation you can read. I will not explain. Heat transfer occur by natural convection because change in temperature cause difference in density. That is very straightforward, very simple concept you can read. Okay, exit is distribution for ideal CSTR e to the power minus t by tau upon tau. So this is the answer. So endothermic second order reaction carried in adiabatic plug flow reactor. The heat generation maximum at the inlet of the reactor. Okay, this is the explanation you can read. Excellent. And always remember that for if this is endothermic reaction is taking place, and this is the T1, T2, T3 and T4. So always remember T1 greater than T2 greater than T3 greater than T4. And one thing, this non-isothermal reactors very well explained in H. Scott Fowler. Okay, direct equations are there. The definition of Laplace. Okay, so you can check that. I don't know the answer. The system with double pole at origin is unstable since the corresponding term in the time domain of system double pole at origin. So we have this portion, this left portion is stable portion. Okay, so if I have root here, 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 I have root here, root here, and I have root here. These are the possibilities I can have root or on this. Okay, so if I have root this and this, these two are same, right? So these are stable region. If this is the stable, so uh, this will ultimately, this graph will come. This graph will come. If I have here, then what should be the graph? And this is the, then it will come like this. Okay, to the steady state. And if I have here, and this is the steady state value, then it will go like this because this is unstable region. If I have here, and this is the steady state value, then it will ultimately get bigger. See, it is going bigger. This same is for this, and this will give a constant amplitude, neither rise neither fall, a constant amplitude. This is full constant. See, constant amplitude. Similar, this is this. Now our pole is what? Double pole at origin. So this pole will give this. A constant line on this, a constant line on this. Okay, this is a constant line on this. Okay, is a constant. This is very well explained in George Stephanopoulos. Okay, very well explained in George Stephanopoulos. This an inverse response. Inverse response. We will see questions of inverse response in later papers. Response. Okay, so these two topics in the George Stephanopoulos are very well explained. Okay, so just go through that. A sinusoidal variation in input possessing through a linear first order system get attenuated. Magnitude decreases because the ratio of output amplitude upon input amplitude is less than 1. Okay. Typical example of physical system under damped YouTube manometer. In heat exchanger, floating head is provided to relieve stresses caused by the thermal expansion. This is the explanation you can read. Okay. Sucrose is a disaccharide. You all know that. I don't need to. Nylon 66. Adipic acid and adipic acid, and second one was I just forgot that name. Nylon 6 is caprolactam. Nylon 6 caprolactam, then cupric acid, cuproic acid. Okay, then there is something. Nylon 6 is dimethyl and forget the name. Adipic acid and 1,3-dimethyl hexamethyldiamine, I think. Hexamethyldiamine. Just see once. Adipic acid is there. Which one of the following is not likely to be constituent of vegetable oil? Not likely to. Vegetable oil. Okay, citric acid there, oleic acid, stearic acid, glycerol is not, I think. Just check this once, I think. The gas which contributes the maximum heating value, natural gas, methane. Hexamethyldiamine, I think. Hexamethyldiamine and adipic acid. Hexamethyldiamine and adipic acid. If I am not wrong. Okay. Let's check that. Okay, so that's all, guys. We have solved section A. Actually, I don't want to solve section A of all the papers because those have very easy question, very easy question. I don't want to give you a spoon feed, right? So bye, guys. Take care.